Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Abu Zainab. That channel is specially created for you and I to come together to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. It's my pleasure to have you once again here, and I wish to acknowledge your steadfastness in staying tuned to the station. Thanks and God bless. Today, we are continuing on our streak of the topic partial fractions. In the last video, we introduced the concept of partial fraction to mean the reverse process of getting the components of a fraction that has been simplified either by addition or subtraction. And then I said that we have four different cases. Case one being that we have distinct roots as factors, as denominator. And then we explain the concept of either using cover-up method or using the concept of comparing coefficients. But essentially, cover-up method was used for the last video. Today, we take it a notch higher by looking at the case of repeated factors as denominators. How does that pan out? Come along and let's have fun mathematically. So we have this question on the board. We have to resolve into partial fractions 2 plus x all over x plus 1 on one hand, the x minus 3 square on the other hand. The fact that we have a square here or a power here, that means this factor has been repeated, hence the name repeated roots. Now, what do we do when we have this category of questions? It's very different from the last video. So we start by saying 2 plus x over x minus plus 1, then x minus 3 all squared. So all you need to do, clearly we have three factors here. When you have this, we have three factors here. X plus 1 on one hand, x minus 3, then an extra x minus 3. We have three factors. One is single, distinct, and the other is repeated twice. So what we need to do here is to create the usual letters, upper cases. We have a over x plus 1, then plus b over, now we break the factors down by having x minus 3 first, then c over x minus 3 power 2. That is the rule, that's the trick. In other words, if this power had been 3, it's going to be b over x minus 3 plus c over x minus 3 squared, then plus d over x minus 3 power 3. So we go the power from 1, 2, up to the last power in the question. So this is more or less the format for solving questions involving repeated factors or roots. So as usual, what we do here is to find the LCM. The LCM of x plus 1, x minus 3, and x minus 3 cubed is simply x plus 1, then x minus 3 squared. As usual, we simplify this. We have a x minus 3 squared plus b x minus 3, because x minus 3 cancel 1 out of x minus 3. We're having x minus 3 left and x plus 1. Then lastly, c bracket x plus 1. That's simple algebra. So, as you can see, we have the left hand side still being equal to the right hand side. So clearly, the denominator of both sides are equal. So we can just simply equate the numerators as 2 plus x being equals to a x minus 3 all squared plus b x minus 3 x plus 1 plus c x plus 1. So at this point, we have to simplify the right hand side. We have a x squared minus 6x plus 9 plus b, then open the bracket, x squared minus 2x minus 3 and plus c x plus 1. So simplifying for that, we are going to have a x squared minus 6 ax plus 9a. Then there we have b x squared minus 2 bx minus 3b. We are simply expanding, then plus c x plus c. So at this juncture, we now compare we collect like terms based on the degrees. So we have a x squared plus b x squared, then minus 6ax minus 2bx plus cx, the x's. Then lastly, the constants, 9a plus c. So what we have done essentially is to collect like terms in terms of degrees. Ax squared, bx squared there, the x squared on one side, then minus 6ax minus 2bx, and then cx. And of course, we have the constants, 9a, yes, something was missing there, minus 3b, and plus c, the constants. So as a way of check and balance, we have how many times here? 1, 2, 3, 4, 5, 6, 7, 8. Likewise here, 1, 2, 3, 4, 5, 6, 7, 8. So we are in order. To be sure you have not left out a very important aspect of it. The next thing we do is to factorize. So we have a plus b all x squared, then plus minus 6a minus 2b plus c, then x, factorizing x there, and lastly the constant, 9a minus 3b plus c. They have no x attached. That's why they are constants. So at this point, we can now properly compare to the left-hand side. So clearly, we have terms in terms of x squared, in terms of x, and the constants. So by comparing both sides, so for the x squared, the coefficient is a plus b. So we are going to say a plus b on the right-hand side. For the left-hand side, there's no term in x squared, hence the coefficient there will be 0. We call that equation 1. Similarly, for the x, we have the coefficient as minus 6a minus 2b plus c. On the right-hand side, the coefficient here is 1. We call that equation 2. And lastly, the constant there is 9a minus 3b plus c. B equal the coefficient to, sorry, B equal my comparison to 2 here as a constant. So we have arrived at 3 sets of equations in A, B, C by comparing coefficients. Hence, we are left with solving this simultaneous equation system to get the values of A, B, and C. So we move on. So easily for us, from equation 1, if A plus B equals to 0, we can easily see that A is minus B. So that means A equals to 0 minus B. That's minus B. So we now substitute this A equals minus B into equations 2 and 3. First into equation 2. That means anywhere we have A, we replace with minus B. So here we have minus 6, A is minus B. Then minus 2B plus C equals to 1. So we have here as plus 6B minus 2B plus C equals to 1. And 6B minus 2B, 4B plus C equals to 1. We call that equation 4. So in a similar way, we substitute the same A equals minus B this time around into equation 3. And 3 is 9A minus 3 plus C equals to 2. So 9A, A is minus B again. Then minus 3B plus C equals 2. Hence, we have minus 9B minus 3B plus C equals 2, which becomes minus 12B plus C equals 2, equation 5. So we have been able to reduce the 3 equations into 2 with 2 unknowns, which is a standard really. So we are going to solve equations 4 and 5 simultaneously proper to get the values of A, B, and C. So we have there 4B plus C is 1. Then minus 12B also plus C equals 2. Equation 4, equation 5. So luckily for us, we have C having the same coefficient. We can easily eliminate by saying 4b minus, that's equation 4 minus equation 5. Hence, 4b minus 12b is going to be equal, of course, C minus C is gone. So you have 1 minus 2. So this is going to be 4b plus 12b equals to minus 1. So 16b is minus 1. Hence, b equals to minus 1 over 16, which is value for b. But luckily for us, from the inception, we said a is minus b. Hence, a is minus b. That's minus 1 over 16. A is actually plus 1 over 16. We've gotten the first two. To now get our C, we can choose to use any of the equations that involve C. I can say, using equation 4, where 4b plus C is equals to 1, C will be 1 minus 4b. And that's 1 minus 4. And b was minus 1 over 16. So that is 1 minus times minus is plus. 4 in 16 is 1 over 4. Hence, 5 over 4. So we've gotten our three values, A, B, and C. A is 1 over 16, B is minus 1 over 16, and C is 5 over 4. So in conclusion, we slot them in their respective positions. So recall that the question 2 plus x over x plus 1, x minus 3, all squared, was written as a over x plus 1 plus b over x minus 3 plus c over x minus 3 all squared. So simply substituting, a is 1 over 16 and half 1 over 16 all over x plus 1. And b is minus 1 over 16 plus minus 1 over 16 all over x minus 3. Then c is 5 over 4, 5 over 4 over x minus 3 all square. So to fine tune the work, we're going to have 1 over 16 bracket x plus 1 plus times minus there, minus 1 over 16 bracket x minus 3, and lastly plus 5 over 4 bracket x minus 3 all squared. And that is the end of the solution to this particular interesting question. It's quite a mouthful, I agree, but it's very interesting. The key is consistency in practice, believing in yourself, and having that confidence. So in summary, repeated root has to do with solving a partial fraction where one of the factors is repeated, maybe once or twice or thereabout. So all you need to do is to get the format to start with. Once you've gotten that, then the rest is easy. Just recall, we are going to have to use the comparing coefficients method. You can't use cover-up method here. It won't work. So by comparing the coefficients, we're going to generate a set of simultaneous equations which will be solved to get the values of the variables. And with that, we come to the end of the lesson today, which I believe you found quite interesting and insightful. If you do, please don't forget to subscribe, like, share, and importantly, tune on your bell so that you'll be the first to know when our next video shall be dropped. And in our next video, we are continuing this interesting topic with unfactorizable factors as denominators. Thank you and stay blessed.